So now in this video we're going to use the 78L05 component again. So this is a voltage regulator. You get 5 volts out in relationship to the ground pin, and usually that ground pin is set to the ground of the power supply, and so you got 5 volts to work with to do whatever you want. But now we're going to take the ground pin, which is the middle pin. We got the input on top and then the output on the bottom there. So it's in the TO92 package right there. About the same package as a regular transistor. The 7805 is a TO220 package, so it's a bigger component with a metal backing that you can attach a heatsink to. But in any case, for this video, we're going to put the ground on the other side of a resistor in relationship to the output. So what that's going to do is going to put 5 volts across the resistor, as long as you got enough supply voltage. So you need at least the data sheet says a couple volts for powering the integrated circuit for the most part. So you're going to lose maybe 2 volts. So if you got 5 volts that you got to put across that resistor, you're going to need at least 7 volts. So that's if that goes to ground. But in any case, 5 volts divided by 500 ohms, to make the math easy, is 0.01 amps or 10 milliamps. So going right to ground, that would be enough voltage to keep 10 milliamps. But we're going to add some series LEDs. We'll progress through that and look at it. So we're going to need more voltage as the load demands more voltage. So you want at least 7 volts plus whatever the load needs. You can go higher than that though. You can go a lot higher, and it's going to maintain that current. So it's a current source, or as the data sheet says that I looked at, current regulator. Now, there's also this capacitor here. I just put it across the supply rails there, but positive supply goes to input. So you can see it goes there. Especially with my power supply, the voltage isn't terribly steady, and so that will help smooth things out. The data sheet recommends 0.22 microfarad. I use 0.47 microfarad a lot, so that's just what I used. Going larger in capacitance should just be even better. It shouldn't hurt anything. And now we come to the power supply. So before you turn the power on, you want to make sure that the ground pin is wired up. If it's just floating, you run the risk of the full voltage being applied to the load, which might not be too bad in this video. But in any case, now we got the output on, and you can see 10 milliamps of current right there. And now I'm going to move the jumper down one spot so that we're powering one of the LEDs. It was kind of sticking there. Yeah, you can see one LED lit up. So the current went way down. We don't have enough voltage. Since it's a red LED, probably 2 more volts will be plenty. You can see we get up to the 10 milliamps. Now I'm going to add another LED in series. And again, I got to go up 2 more volts. And then another one. And there we go. So it says 11 milliamps of current. It was, probably in the range. Plus, it's not as accurate as a multimeter. But in any case, we will go up to 20 volts, and we could go higher, but I'm not going to, because right now we got 3 series LEDs. We're going to work our way down. So now there's 2. You can see the current held the same. We got quite a bit less load. Now we have a lot less load, just 1 LED. It's still maintaining that current, and we'll go to the resistor right there, which is far less load, about half the load probably, of those other 3 LEDs put together. And you can see the current still maintained. So the voltage, supply voltage, can change quite a bit. And we have a set current though. So in any case, this is my quick video series. This one went on too long. So I'm going to end it there. Thanks for watching.